All right, everyone, welcome back to CS160. All right, lecture 2. Let's get started. As last time, I thought we'd start this lecture off as well by just looking at some examples of user interfaces. And last time we looked at kind of vastly different types of UIs, whether they're 2D or 3D or multi-touch. For this lecture, let's just look at very small details in interfaces and think about how those can make a difference. So here's the font selection dialog in Apple's Keynote. And here is the font selection dialog in Microsoft PowerPoint. Now, one thing that we'll do throughout the semester is compare and contrast different designs to each other, because it's much easier to draw contrasts and differences than to say whether something is globally good or bad, or better or worse. So who wants to take a stab at comparing the Keynote and PowerPoint font designs? And please, once again, tell me your name first.
I'm Kayvan, and my first thing that I noticed was the font name in the PowerPoint has been written with the same font that they are representing. But in the Keynote, all the names are in the same font and they represent different fonts. So.
Great. So I'm just going to repeat some of your comments for the video, which we're recording, because we got the feedback that we don't have any microphones in the audience that are actually on. So Kayvan's comment was that the names of the fonts are rendered in the font in PowerPoint, and they are not in Keynote. And so there may be an upside and a downside to that. Anyone want to speculate? What's your name?
Achal.
Achal?
Upside being that you don't have to try multiple fonts to see what you want and see it in the selection. Downside being blinking.
Yeah. So the upside is you actually, maybe you don't need to remember the name of the font. You can just look for something that looks like the font you're looking for. The downside is not all fonts are in Roman script. So if it's a symbol font, then how do you know which of the 10 symbol fonts that all give you thumbs up is the right one? Okay. Other differences in these interfaces. We'll go back there.
We can see that the commonly used ones are listed on top, and it could be really convenient for people who know how to use that, but for people who are not so used to it, it's weird that you have stuff that's really out of order on top.
Okay, so there's something going on up here, right? Which is that in PowerPoint, frequently or most recently used fonts are shown towards the top. So one benefit is that this may reduce your mouse distance that you have to travel. It's kind of right there under your mouse, and we'll operationalize that distance and how long it'll take later on in the course. And then you said there was also a potential downside to that, in that not everyone may know what these things are. Who knows what font collections are? Okay, what are they? Why would I use them?
It's another way to group fonts by type, like proportional fonts or fun, casual fonts, things like that. It's just another clustering way to cluster them and organize.
Yep. So one thing we're running into here, it's another way of clustering and giving you a different slice of your of the selection of fonts on your system. One thing we're running into here is more choices. Each of them may be good by itself, but what happens when you give me 5 different choices within the same dialogue. So you see, even at this like microscopic level of how do we show you a list of fonts, there are quite nuanced and subtle decisions that, that you can make that affect the usability. All right, let's do the same thing, but with your homework assignment. So here are 2 tip calculators. I think this one is slightly different from what I showed in lecture last time. So you enter an amount for the check, choose a tip amount, split, and everything's kind of here on one screen. Right? This is design 1. Let's look at design 2. And this one you have seen last lecture. This is the tippy tipper. So you first enter the amount, then you get to this tip percentage where you can round up or round down, and then there's a separate. All right. Who wants to take a stab at comparing these 2 interfaces? Second row? What's your name?
Tim.
Tim?
The first one, you didn't have to switch between screens.
Yeah, so the first one, all the information interaction was on a single screen, and that is good. Why?
Oh, because it just feels like it's less work and less troublesome.
Okay, less work, maybe more efficient, right? Yes.
My name is Eric, and on the second one, you already have the keyboard there, so that has big numbers rather than having to pull up the built-in keyboard and go to the tiny little numbers.
Yeah, so the second design had a custom number entry UI. The first one just pulled up the soft keyboard, but the soft keyboard is not optimized at all for entering numbers. Right? So we actually dedicated a lot more of the screen real estate to entering numbers, which is all you're going to do in this interface. Okay, other comments? In the back, gray and black striped sweatshirt. Sean.
So you make a mistake, you know, right here, you have to go back 2 screens and then re-input it, and then you have to go through all process again. On the first one, you just select the box right there.
Yeah, so you pointed out the very important topic of mistakes. What happens when something doesn't go as planned? And that can either because I made a wrong plan and I changed my mind, or I actually had the right plan but then took the wrong action. And thinking about errors and mistakes in user interfaces will be a very important topic in your own class projects as well, because they occur much more frequently than we as designers would imagine them to and like them to. So how does the system respond, or what kind of accommodations does the system make for you to undo and change your mind? And as you rightly point out, here I have to go back potentially 2 screens to the beginning just to be able to change the amount of the check.
Also, the first, sorry, go ahead. The first example that you showed, rounded, like showed the thousandth place on the total, which is ridiculous, right? I mean, there's really no upside to that unless you're really worried about how you're rounding your pennies. But and then this version rounds everything down at the 100th place, which makes a lot more. It's more intuitive, makes a lot more sense.
Yeah. So rounding from an implementation perspective can say, well, of course I can divide by 13 and give you any number of significant digits, you know. But from the user's perspective, well, what are you going to do? You only have cents. And even with cents, you most likely don't want to deal with them. Maybe you only want to deal in whole dollars or half dollars. And that is precisely the kind of user-centered insight that you want to have that will improve the design of your application. And it's really paying attention to those details is important. All right, let's talk about enrollment. So decisions were sent out on Friday. Everyone who entered a valid email into the petition should have gotten a notification of either thumbs up or thumbs down. We did have to cut down from 200 to about 100 people. So unfortunately, this is not the type of class that you can easily scale to you know, a large auditorium because of the design projects. Now, if you're still undecided whether you have enough time to devote to this class this semester, drop us a line, drop the course, let us know by this Friday at the latest, because on this Friday we'll assign the groups, and then really you're letting your group members down if you decide to drop afterwards. And as long as people keep changing their mind, which in the second week of class is perfectly fine, we'll keep assigning the open seats to people who are still on the wait list. The official database update has, I don't know, 24 to 48 hour latency, so go by the emails you've received from us about your enrollment status. If you've received an email and not seen anything change in Bearfax in 3 days, then send us a message on Piazza and we'll go investigate what happened. Okay, everyone who is enrolled should also have been assigned to a section now. We have 4 sections, all on Thursday. Please attend the section that you were signed up for or that you yourself signed up for, unless it's really impossible. And then we can have a couple people move around, but not on a larger scale because, as you've seen, the room we have is limited in capacity. So we'll just go with that until you know, attendance really becomes lopsided and a problem, and then we'll figure something else out. All right, quick review of what happened last Wednesday. I told you there was one slide that you should remember, and that is that design is iterative, and we're going to go in more detail on that today. Then, just to remind you, the project theme for this class is going to be designing, prototyping, and implementing mobile applications. We're going to do this using the Android SDK. First homework assignment on Android is already out. And then for the course mechanics, all info is on our course wiki. So really everything should be found there, and if it's not there, ask a question on Piazza. Don't email me directly or any one GSI directly. You'll have a greater chance at a faster response if you send a private message on Piazza if it's a private matter, because then all of the staff sees it. All right, this was due about 10 minutes ago. You were supposed to go to the wiki and create a wiki profile that tells us a little bit more about you. You've already done that in the petition, though, so the second reason is we just want you to become a little bit familiar with the wiki syntax now when it doesn't really matter, as opposed to 10 minutes before the deadline of your assignment when it does matter. The other thing that was due today, just a reminder, is the reading response, and we'll assign these readings for almost every class. And you should all be familiar with this. This was the Google form. What you haven't seen yet is that we then take all of your entries from the Google form, and basically we have an export script, and then we put them up on the wiki so you can see what the rest of your class had to say about the readings. And this we'll try, well, we'll see. Either we'll do this after class, or we'll move the deadline for the responses maybe to noon so we have enough time to get this up before class. Yes, Glenn?
So the response, how do you want the responses formatted? Because I included the original questions in my responses, which is going to be a pain in the ass for the script, right?
The script is fine. I mean, we'll just get the, so here, for example, is the question again. That is fine. What the script is less robust with is if you draw ASCII art in your answer, which, you know, people do to show you diagrams, and then we kind of have to fix it manually because we haven't quite yet found the right escaping script for the wiki text. But yeah, you can state the feel free to state the question again if it helps you structure your answer. All right, other questions about the reading responses? Yes, last row.
How are they going to be graded? Is it based on completion or based on the quality of your response?
Funny you should ask that. So the main point of the reading responses is for you to convince us that you've carefully thought about the assigned reading. And so basically we have this scale, which is most everyone will be in fine, which is, yeah, I've thought about it, here's an answer that's reasonable. Then if you really want to go out of your way, you can give an exceptional answer. Maybe you give other examples related to your own past experience with other user interfaces. You're totally fine here. A couple people will put in the extra effort for exceptional answers. I encourage you all to do that. Not everyone will have the time to do that every week. Then there's lacking, where we feel like you've maybe briefly skimmed the reading and you're basically giving us a version of the question or something that indicates that you haven't really thought about the reading. Those tend to be the answers that appear like 5 minutes before class starts. And then there's no answer. And you can see no answer penalizes you quite a bit more than a lacking answer, but even a lacking answer can still potentially pull down your participation grade, where if you just give a fine answer, you'll be good to go. So we're not going to grade them in any more detail than that because there's a lot of them every class period. And it will probably take us 1 to 2 weeks of latency to catch up. We will try to give you some form of feedback of how you've been doing with the reading responses, just by sending you the scores kind of in batch. Yes. Yeah, we'll try that. So I uploaded the ones for this week at the end of last week, and then in the next, by Wednesday, we'll try to have the readings for the entire next week. And that's actually, that's good because there's not that much time between Monday and Wednesday, right? So it's in your interest to read up ahead a bit. Yes?
What's the ideal length of a response?
So, well, what's the ideal quality of the response is the more important question. So longer is not necessarily better, but I would believe that any concrete question we ask is going to take at least 2 to 3 sentences to answer, right? So you can think roughly it's about a paragraph, a short paragraph per question. You can write more. You don't have to write more if you feel like you've made your point, you've thought about it well, and that is what you have to say. All right, due next Wednesday, next reading response. The reading is up. This one will require a login and password, so that's on the slide, and the link to the form is also already up. Sorry, this Wednesday, yes. Thank you. All right, final reminder, Friday at 5 p.m., you have 2 things due, the individual design exercise and the programming assignment, and I hope, who started the design exercise? Okay, everyone who's not raising their hands, you really wanted to start yesterday. Just because some of the steps are things that you cannot do by yourself sitting in your room at 2 a.m. in the morning, right? You have to find other people, interview them, give them something to test, and just the coordination of that takes a while. Otherwise, it's not the most work-intensive assignment, it's just coordination-intensive, so that's why you should get started early. And then programming assignment 1 is also out, tip calculator. If you don't have a personal laptop and you need a lab, we have, I think, about a dozen machines or so in 277 SOTA that we set up with Windows and Android. They're nice machines with, I think, 16 gigs of RAM. So feel free to go there. We haven't stress tested them yet. We had a couple people log in. So you may run into some problems. If you do, please let us know on Piazza right away so we can fix it for everyone else. All right, just a note on the design exercise, the point is not to implement one of the couple of examples that are listed in the assignment, but the point is for you to kind of go through the design cycle and come up with lots of ideas on your own. So we want you to have at least a dozen ideas, then pick the best one of those, quickly prototype it, and evaluate it. All right, help with the programming assignment. Well, the first office hours for this week already happened. They were right before class. We have office hours tomorrow afternoon and on Wednesday right after class, and then there's section on Thursday. Please attend your assigned section, unless you have a really good reason, and then try to sneak into one of the other ones. I also recommend that really the authoritative documentation that's fairly well designed overall is just the Android programming guide. So if you just work your way through the building your first app tutorial on the Android site, you should basically have all the skills needed to do this first assignment. And to just steer you to what to pay attention to, here are some of the things you will definitely have to learn about how to do. So you have to be able to create your own layouts and widgets, and Eclipse comes with a GUI builder for that, or you can edit the XML files. I would recommend the former, but you can do either. Then you have to find out how to refer to whatever you created in your GUI statically in your code at runtime. And so there are various methods by which you give an ID of something in the UI, and you get an object back in your code. You have to know how to learn those, and then how to add event listeners. So when something happens, someone clicks on a button, how do you get the right callback in your code that that event has happened? And then you need some method of showing output on the screen. And basically with those 4 ingredients, you'll be good to go for this first assignment. Other questions about the assignment? All right, everyone's happy? Then let's move on to the main topics for today. We're going to talk about the design cycle in more detail and about brainstorming. So let's get started. So in a nutshell, this was the process we talked about last Wednesday, and let's just break this down into a couple more stages. Before I do so, though, let me give you one caveat, and that is that a souffle is eggs, buttermilk, and flour, but whether you get a souffle or gunk is all in the execution, and the same is true of UI design. And so basically what we're going to try to find out is what is the process that, given a bunch of ingredients, results in a tasty souffle or a tasteful UI, and not the opposite. Now, that is a guideline. It maximizes your chances, but there's still some element of art, right? Everyone can learn how to cook decently tasty meals. Not everyone will become a Michelin chef. All right, here's a different version of the design process. This is from Coburg and Bagnall. And if you look around there, basically, you can find a number of different cyclic models. And I just picked this one here because it's a little different from what we talked about last time, a little different from your reading, and it has more detail that lets us make some distinctions. One thing to point out right in the beginning is that implementation is the 6th step. It is definitely not the first step. And even though many other courses in this department rightly focus on implementation, because there's a lot of disciplinary knowledge to learn how to correctly implement applications, in the larger sense of how you go from an idea to a shipping product, it is a 7th. So let's just start at the beginning. Acceptance. What do you mean by acceptance? Well, that is how you even get to getting started on a project. And that may be because you have a deadline, because you're forced to, because you're taking 160, or because of a possible reward, right? You can enter like an app challenge with a huge prize. When you accept the problem, a design problem, you also have to kind of make a commitment at that time. How much time am I going to have for it? What resources, and who's going to be responsible for what? And the key here is really to set the motivation for the project, because if you don't believe that this is worth doing for the right reasons and you have the right resources, then maybe you should not accept the assignment. Say, well, given the time we have, can't do it, or we need more developers. That is, by the way, not an acceptable answer in CS160. All right. Once you've accepted your design problem, the next is analysis. So you have to understand your users and their tasks. So who are they? What are their tasks? And why are they engaging their tasks? What's the larger function that is being served here? And the number one lesson there is distrust your intuition and don't guess. Rather, observe people and ask them. Because our intuition frequently leads us astray, especially when you design applications for users that have different demographics from you, different jobs, different experience backgrounds. Your own lived experience does just not prepare you for their needs. Now, your main tools here are, we used to have this long list that basically said, you take a camcorder, you take an audio recorder, and make sure you have this piece of gadgetry and that piece of gadgetry. And nowadays, just bring something to write on your smartphone. So make sure when you observe, you want to capture what you've seen, because you're going to forget, especially if you have multiple of these interviews. So you want to capture video if possible. You want to capture still images, audio, just as rich of a record of what you've observed as possible. And we'll have a whole lecture actually on just this process. So here we're going to borrow techniques from anthropology, from ethnography, from journalism, and apply those to just rapidly immerse ourselves into the world of the target user. All right. Next stage is problem definition. And this is something that is a bit tricky for engineers, because we're not very well trained to do this process of problem definition right. Problem definition is basically problem setting. So you redefine what the question is that you want to answer based on what you've observed. And there is this fine line between making it your question way too broad or making it way too narrow. So here's a great example. Let's say you're a bicyclist and you also like to drink coffee on your way into Soda Hall. Well, traditionally, bicycles have cup holders on the down tube. It is not that great for hot beverages. You have to look down there. Maybe you'll spill on the way back down. You have hot liquid running over your hands. So the design company that came up with this handlebar holder had the idea of saying, well, it's not how to make the best down tube holder for a coffee cup instead of a water bottle. It's how do we help cyclists to drink coffee while they're riding their bike. Right? So it's like a different framing of the problem that takes you away from, oh, we got to build something that attaches to the frame down here, to we got to build something that helps people drink coffee. And this kind of reframing of a problem really will help you envision new types of solutions. All right, so once you've defined your problem, then it's time to just come up with ideas. And there are many different mechanisms by which you can have ideas. One that works fairly well is brainstorming. So what does brainstorming mean? Well, someone want to give me a definition of brainstorming? Anyone? All right, and your name?
My name is Dennis.
Dennis.
And one example would be just writing everything that comes to mind.
Okay, writing down everything that comes to mind is a component of brainstorming, but there's more to it.
Brian, I guess, let's say it's like the process of generating ideas would be like the definition. wide array of ideas
Okay.
for a particular problem.
It's a process for generating a wide array of ideas. And yes, that is a kind of all-encompassing definition. So what I want to point out here is that it's not just let's all get in a room and come up with, you know, anything that's on our mind. It's actually fairly structured, where you accept some conventions about what you're going to say and what you're not going to say in a way that has been, you know, shown or is thought to lead to very good outcomes in terms of the quantity of ideas and hopefully also in the quality. So here are a couple of rules. We're going to spend the last 15 minutes of this lecture just talking about what they mean in detail. All right, so the outcome of ideation is hopefully many different ideas that are applicable to the particular stage you're in your design cycle. You can't do them all. So a typical brainstorm can easily generate 50, 100, more than 100 different ideas. You're not going to do them all. So how do you choose? So that is the role of selection. So now you have to establish some criteria by which you're going to evaluate the ideas you've come up with. Now the important part is actually to separate the two stages. You don't want to evaluate right away while you're having ideas, because that can stifle your creativity. So come up with all the ideas first, then say, okay, now we're done with coming up with ideas. Let's evaluate which of these are a good fit for our requirements and which of these are just too wild and crazy. So you define a couple of different dimensions, and then often you can basically create a matrix of ranking ideas according to different characteristics or concerns you've come up with, and then you just pick the top n. Sometimes n equals 1 towards the end of the process when you can only do one implementation, but especially in the beginning, you can pick n, 3, 5, 7, so you have multiple ideas still in play. All right, and only then do we get to actually creating something concrete. But implementation can also have many different forms. So you can start with low fidelity, quick, cheap, dirty prototypes, sketches on paper, which you're going to do for your design assignment, paper models. Maybe you take foam core, which is this material, cardboard with foam in the middle, to build a kiosk if your design is a kiosk system. And then next time around the cycle, you're most likely going to scale up in fidelity. So HTML mockups, Flash, etc. And then only at the end, because it's the slowest and the most expensive, would you do the full interface. So there's both a question of, are we doing everything in the interface or just a small aspect of it? And then are we using the implementation technology, or are we using some stand-in technology that lets us suspend disbelief, simulate what it's going to be like, but is much faster and cheaper? Let me just show you an example of what this may look like. So in web design, here are 4 different types of prototypes you often see. So people initially will define sitemaps, and sitemaps define the structure of the website. It's like conceptually the information architecture. So what type of information is where? Is there a login screen? Is there a forgot password screen? Right? And how do those link to each other? Then you create storyboards, which are particular sequences through the full site. They're not everything. They're just, maybe for Amazon, right, the common sequence would be, I browse, I find a product, I add it to my cart, then I sign in, then I provide my credit card information and check out. So that is one particular story through the site. And you'll pick the most likely and most important stories and kind of flesh those out by sketching them out. Then there are schematics, which are, well, what type of information goes in the page where, without having the full design. So it's basically you can think of it as a more detailed version of the sitemap. And we're now at what links and what information exists at the page level. And then there's the mock-up, and here's what it will look like. So these are all different concerns, and it pays to address them separately earlier on, because each of them will be faster and cheaper to construct in isolation. All right, so once you've created one of these prototypes, the purpose why you created it in the first place was to get some feedback of whether you've achieved your design goals or to get answers to specific design questions. So that implies evaluation. I already told you on Wednesday there are many different types of evaluation. Some of them are as easy as turning to your neighbor and say, here's my mock-up, what do you think? Or better, here's my mock-up and a specific set of questions. Could you please try to do this task and let me know whether you get stuck somewhere? Or you can actually get people into a lab. There's a lot of space in between, and the type of evaluation depends on the stage, how early on you are. If you only spend 5 hours creating a prototype, doesn't make much sense to spend then 2 weeks recruiting subjects, getting them in the lab. But it also depends on the type of question you want to answer. So let me just give you one example of a concrete technique that you will employ later on in the semester. This is called Wizard of Oz testing, or also paper prototyping, where you sketch your UI on pieces of paper. So you will have different papers for different screens, but then maybe also different papers for parts of each screen. And then you give a user a task. For example, you say, here I've sketched out my mobile interface to find news on Berkeley's campus, find out what's going on in the CS department today. And then I'll say, okay, well, what can I do here? Let me click on search. And then the computer will say, you clicked on search. Hold on, let me get the right interface. You now see this. What do you do next? Right? So the computer, the person will just simulate the logic of the UI, which you've discussed before, but which actually hasn't been coded up at all. And that also gives you, you can do this at any time, and it gives you the flexibility of changing what the logic is on the fly based on user feedback. So it's a very lightweight technique to find out whether you've obviously missed entire areas of functionality, and also to get at small usability problems. All right, and then something I also mentioned on Wednesday, I just wanted to revisit, is that the number of ideas you have at different points in your design cycle kind of goes up and down, and it has to do with going through the cycle, right? So you start with having nothing, and then you go through ideation, and in ideation the number of ideas explodes. Then you have selection, you filter ideas back out, then you have to make some of them real. Because of constraints of how much time you have, that usually means doing that for one or just a couple. You evaluate it, you let that drive the next iteration, and then you generate more ideas. And so usually you have this fall off curve over time, because in the end you will just want to end up with a final product, but expect to kind of go up and down this roller coaster as you go along. So why do we get more ideas in the middle? Why do we need to generate more ideas? Well, because most likely your evaluation tells you about problems in your interface. And that forces you to come up with strategies to fix those problems. Oftentimes it's not obvious what will work, so just come up with alternatives. 3 different ways to address the problem. Think about them, maybe test a subset of them, and work your way through the cycle. And then your prototypes, well, as I told you before, they kind of increase in fidelity over time. All right, I thought maybe we'll do a quick mapping so you all read the Lewis and Riemann reading for today. Here were their headings, how they conceptualize the design process. So let's just map them. What stage does who will use the product map to in this cycle? Analysis, 2. Okay. What are their tasks? Also analysis. Plagiarize.
Idea selection.
Something around here. Okay. I would argue, right, plagiarize was about looking around for other solutions and letting that inspire you and borrowing from what works. So this is really in creating possible candidates. So I'd probably map it under ideation. Let's just do one or two more. Thinking about a design. So here, ideation and idea selection. Yeah, it's really a selection task, right? Because you've come up with the ideas, and now you take a step back and reflect, are these good or not? What do we know from cognitive science or psychology to tell us whether that idea might be better than another idea or not? So bringing your background knowledge to bear before you implement something. All right, just for completeness, this is in the slide deck, so if you look this up on the web, you'll have a complete mapping. Okay, so in a nutshell, it's a cyclic process, and I just wanted to kind of wrap up this discussion by showing you a contrast. So the contrast is the waterfall model. Who's heard about the waterfall model before? Okay, so this was a classic model of software engineering. If you take CS160, you will most likely not learn about the waterfall model, or it will be presented as, you know, something we've overcome in the field. Now, there are some good aspects and some reasons why this model was presented as a model of how software engineering should happen, right? Because so it says you start with a description of what the application should do. That leads you to specify requirements. Then you do the design. And then you do the final implementation. Now, a potential problem with this waterfall model is it's very linear. And hopefully, one thing I've communicated to you so far is, why do we do iterative design? Because we get things wrong all the time. And if you move through a pipeline and you determine somewhere down here that you've made a wrong assumption in the beginning, it may be too late. So the primary benefit is that you have this feedback mechanism that corrects the errors you necessarily will make because you're acting on imperfect information throughout the design phase. And empirically, it's been determined that, you know, with each stage of the waterfall model, it's about a 10x increase in the cost to fix a defect. So if you find a defect, wrong information architecture, when you sketch something on paper, well, you just take another piece of paper and sketch something that fixes that mistake, and you're done. If you find it after the product has shipped, right, now you're already in the straitjacket of how you've architected your code, and you have to unwind that, hire developers, and basically do part of the early process again just to fix this detail in the implementation. That gets extremely costly. So that's one of the main reasons why many people advocate for a cyclic design process where you keep the cycles fairly short. Yes?
One thing, because I've worked with both processes, I greatly prefer the first one rather than the waterfall. But one thing that came out of the waterfall process that was actually beneficial and helped that the first type, that cyclical type, is really forcing the users to think through as much of the functionality as they possibly can, right? Because with people knew with the waterfall model that like changing stuff down the road was hard and cost money and resources. So it really you really put a lot of effort into making absolutely sure that you had all of the paths and structures, even though they would be wrong later on down the road. But instead of like, okay, here's the first 3 screens, what do you do? And then, okay, now I'm going to fix it and add some more stuff. And now what do you do? And add some more stuff, rather than getting as much up front as you possibly can to help you kind of structure things.
Yeah, so Glenn makes the excellent point that if you know this cost structure, you're going to make damn sure that you didn't forget to, dot your I's and cross your T's in the early stages of the waterfall model. And I think you're right that that does translate to iterative design. Just because you're going to have, you're going to have another cycle later on, should not be an excuse to be sloppy and abdicate your responsibility to actually do the design, right? You shouldn't just be building a bunch of stuff because you will build more stuff. So that's why also in the Lewis and Riemann piece, there was this stage of really think about the ideas, the proposals you've made, and how they address the needs or not, and whether they're completely spanning or not. So I think that's that's an excellent point. Yes.
What happens is it's very expensive to test, or it's very difficult to have the feedback from the user. Because in the entering model, it's supposed that you have like constant feedback from the user, but there are maybe sometimes when you build an application and you don't have.
Okay, so what happens when it's really expensive to find the target users and test with them? So let's move from hypotheticals to a concrete situation. Who has a concrete situation where it may be difficult, costly, or next to impossible to find your users or to have them test your application frequently?
Maybe some sort of, maybe some sort of a space software, like shuttle software. You can't really launch shuttles all the time.
So space shuttle software, they're actually not up in space for a long time. But you can probably go through simulations, right, as lots of pilots do before they ever get to fly a plane. So think about how you can step away from testing in the final situation. Is there some other environment that approximates the final situation that will still give you useful feedback that is not as costly as sending a rocket into space? Okay, there were some other hands up. Yes?
If you're designing like for a developing country, then it would be really costly to actually have to fly to test if the actual people could, your users within your home country.
Yeah, excellent point. If your users are remote and you don't have access to them, what do you do? And so the strategies that have been employed are you find a local partner somewhere else and have them interface with the user. So it's not going to be you, but it's someone else you contract with that has access to that user base. Or you find proxy users that don't have all the characteristics, but have some of them, and they have the benefit of being close by. All the way in the back. Yeah, so, and there's actually two aspects to that. It will be really hard to get surgeons or other highly trained professionals to give you a lot of their time, because their time is very valuable and very constrained. And so that tends to be hard to find those users. And then the devices themselves, right? There may be FDA regulations, et cetera, and it may be hard to test a functional device. So once again, you take a step back and say, what can we do that's maybe not quite the target user, not quite the target situation, but allows us to get feedback? And one strategy you can always apply is to find other expert designers who are good at putting themselves into other people's shoes and have them simulate, role play being one of the users. Now, all of these methods are imperfect, but they're better than not doing any testing. All right. I wanted to show you the design process in action. So for that, 60 Minutes ran a couple of years ago a segment on how the design process works at IDEO, the product design consultancy. They're in San Francisco and Palo Alto. And so it's a really nice piece. It's about 15 minutes long. Just show you of what a complete product design cycle, going through it multiple times, looks like from start to finish in a really compressed amount of time. All right. Let's get some lights back on here. Okay, so maybe some reactions. What do you see in terms of following or not following the cycle in the video?
My name's Sean. They spend like the majority of the time analyzing the user's needs. Like they spend a lot of time on the design process rather than actual implementation.
Yeah, so you said the building of the final cart was the last night, right? There were other prototypes constructed in between, but the real building of the cart was just the final night. Now, you can do that if you have an expert machine shop at your disposal. You may have to start a little earlier for your class project. Glenn?
They didn't get any feedback during the time that, I mean, they got internal feedback, but they didn't get any external feedback from people as they were doing the iteration.
Yeah, excellent point. From what we saw here, I saw them going out twice. In the beginning, to interview and observe, and then in the end, to evaluate the final product.
Blame the final product. Because I did it correctly, it shouldn't have. But wouldn't it be correct to say, like, so at the end they had the card ready, but they showed it to the supermarket store, so they could use like more changes.
Oh yes, absolutely. I mean, it was the end of the show, right? If you were actually going to manufacture a new shopping cart, you'd be still in the early stages. But you're right, we didn't see. What we did see was designers reacting off of each other and saying, well, this could work, no, that's not going to work. So using each other's expertise. But yes, they would have probably done even better going out or bringing users into their studio. And one of the things you have to negotiate is when things are still rough, when they're, you know, in this case for physical product design, when they're just bent wire and foam core, is to what extent you have to frame this to the user. The target users are not design experts, right? So they're not used to seeing something that's really rough around the edges. And so part of you as a designer is to set the conversation and explain that this is an early prototype and that they have to suspend disbelief and kind of play along. And once they've gotten over that hurdle, then oftentimes lots of good insights come out. Yes?
Not entirely related to it, but I found it interesting that they did everything in the model of a grocery shop, or like a general shopping cart. So like anything to do with bigger stuff, like even if it's groceries.
Yeah, so this was redesigned the shopping cart for a grocery store. And, well, that's what we saw, right? And you're absolutely right that this may not work for a shopping cart for Target. Or, yep, Ace Hardware. So that comes down to problem setting, right? And it is actually beneficial if you can say, we're going to make the shopping cart that works best for Ace Hardware. Or we're going to make the shopping cart that works best for if you go to Whole Foods. Because it gives you more constraints and makes it easy to decide whether something is good or bad. All right, I think we got to move on because we have a couple more slides. So what we did see in there was this whole segment on brainstorming, generating hundreds of ideas. So since this is what we will spend next Monday on in class, I thought I'd just give you a little bit more material on brainstorming, and we'll start with the psychology of creativity. So conformity is the enemy of creativity. And anyone who's ever been part of a club or an organization they identify with, like Cal, right? You know there's some pressure to go along with the brand or the identity of that place and that organization. And that is great for building cohesion within the organization, but it's not really what you want when you want to be creative and get lots of different ideas on the board. Because the pressure to conform kind of, it affects your judgment and your perception. So the tale of the emperor's new clothes, or, you know, looking back to our own history of McCarthyism, tells you there's this danger of not being one to perceive not wanting to be perceived to be in a minority, so you go along with the majority opinion, even if you don't believe in it, and you actually end up manufacturing your own explanations for why that might be a good idea or not. And that is something you want to steer clear from when you're coming up with ideas, right? The last thing you want is to convince yourself that something that you knew was kind of a bad idea is what your team really should do. So if we want to look at role models for creativity, and you can look at dissenters. So dissenters who really disagree with the group can be difficult for the group because it's not as comfortable as if everyone just sits around and nods their head, but it really can enhance the creativity of your group as a whole. And they don't even have to be right. Just like you saw in the brainstorm, like Velcro seats and Velcro pants. That's probably not the right solution for the shopping cart, but it just puts another point on the map that allows you to react to it and maybe to take some tangent off of it that gets you to some concrete space. So the originality of the minority really can stimulate the group as a whole. Does anyone know who this is, by the way? No? All right, you got to brush up on your civics. This is Stephen Breyer, Supreme Court Justice, and he's actually born in San Francisco. When he grew up, he would debate Jerry Brown in high school, and I think on the Supreme Court, it's really important to have these dissenting opinions, right? And they get written up as dissenting opinions so others can see what the counter argument was. So the country as a whole can then take both the majority opinion and the dissenting opinion and take that as input into, moving as a whole, changing what we believe is right or wrong and acceptable or unacceptable in our country. All right, so dissent is good, but it has to be real. It has to be authentic. So if you just designate someone as, hey, play the devil's advocate for the next 20 minutes, everybody knows that that person is playing the devil's advocate. So it's easy to discount whatever they're saying. So you want to have authentic dissent, and you want to encourage it to, so not just politely nod and move on, but actually think about what someone had to say who had a different opinion from you. All right. Many people have probably seen this. So there are many of these kinds of puzzles, right? So your goal here is to draw a series of 4 straight lines through all the points below without lifting the pen from the paper. Who hasn't seen this particular puzzle? Okay, so you guys, I'll give you a couple of seconds to think about it. How are you going to draw 4 straight lines without lifting the pen from the paper so it goes through every single point? Here's a solution that works. So why do we have this on the board? Because there's this crucial twist, right? To actually solve this problem, you can't restrict your frame of thinking to be like, okay, how do I draw within that box of 9 points? You have to reframe to say, okay, I can draw the lines anywhere on the larger canvas, and the lines just eventually have to go through these points. And you'll often find in framing problems that it's that similar kind of reframing of what you think you're doing that really gets you to new ideas. All right, so why is this hard? Well, because we have these conventions that we implicitly adopt, and we may not even know that we're implicitly adopting them. All right, so let's quickly go through the brainstorming rules in the last couple of minutes. So there are a number of rules, and we'll go through them one by one to get you to a more productive brainstorm. The most important goal is aim for quantity. You want to have as many things on paper at the end as possible, and hope for quality, that there'll be some diamonds in the rough within that quantity. Okay, first step is sharpen the focus. So back to our bicycle cup holder, you have to set bounds, what's within bounds and what's out of bounds for your particular brainstorm. So you have to be loose, but also disciplined in that if it's bicycle cup holders, you're not going to talk shopping carts. The second one seems very obvious, but is tremendously useful. You want to number all your ideas. It gives you that internal motivation to kind of go to 50, go to 100, and it also makes it really easy to refer back, right? It's hyperlinking on paper, so you can just refer to a number, and then ideas kind of get an idea of their own. It's not Bjorn's idea, it's 53 that you can talk about. There are two very important concepts. One is building on ideas, and the other one is jumping. So you want to have both breadth and depth. So if you have an idea, maybe try to just change it a little bit and see if that generates another idea, but you stay within the same general topic. You do that for a while, and usually then eventually you run out of steam, and that's the right moment to say, okay, we're done with, you know, shock absorbers and bumpers, let's move to something else and restart from there. And so you want to go back and forth between elaborating ideas and just bouncing around in the design space to consider something completely different. That just keeps the momentum going. All right, premature rejection of ideas really can kill both your energy and prevent you from ending up with a good design. And so one skill that you should learn is to just suspend disbelief for a while and during a brainstorm and just let the crazy ideas arise, write them down, paper is free, right? And only afterwards reconsider. Now, as you get better, you may develop more of an internal intuition for what's just a flaw that can be fixed in redesign and what's just really out there and will never work. But especially in the beginning, it's okay if you have those ideas that will never work down on paper. It helps you through the process. It's just a stepping stone on the way to get to the good ideas. Now, space turns out to be really powerful and useful, so don't just say ideas, always write them down, and even better, be visual and sketch them out, and then surround yourself with all of the ideas that your team has already had. Turns out to be enormously powerful for getting you to make new associations with what's already around you. So here's, for example, this is a snapshot from the last time I taught this class. It was one group. We're going to take over the walls for the brainstorming exercise. You're going to go into teams, and the team just used the entire glass wall, and you can see these clusters with different offshoots. So this is building, right? One cluster idea, apps for parents, lots of examples there. And then they jump to apps for fine arts or for law enforcement. Totally different, but then each cluster has detail associated with it. Oftentimes it can be a little awkward to get going with a brainstorm, especially if you're meeting the people on your team for the first time. And so there are a bunch of warm-ups you can go through. It's things like word games, association games, or even come up with a brainstorm on a completely silly topic that has nothing to do with your app. Do that for 2 minutes just to get people talking, and that turns out to be very useful as well. Props are great, so if you've had the topic ahead of time, and you have some time to prepare, for example, toy designers will go to Toys R Us and just pull the latest things off the shelf just to see, you know, what the electronics are, how the mechanisms work, and let them give draw inspiration from that. Right? It's similar to this plagiarize idea from your reading. And then finally, you want to be visual, but also getting physical is really helpful. So make a prop that represents your phone, and if it's, let's say, an application that's like augmented reality, right? Hold it up, play out, act out what the app would be like, and that helps communicate how things work to your team member. Yes?
Just to touch that plagiarizing idea, what can you say about something like canceling an app? Is that safe to do today, or is it not?
So there's a difference between plagiarizing an intellectual property, which is kind of one discussion, and another one, the way that plagiarize was used in your reading, right, was the fact that you shouldn't be afraid of looking around what others have done to get inspiration and to find out what works. Now, it still doesn't absolve you from then thinking through the design and really doing the implementation on your own. But to get ideas of what works, you shouldn't be afraid to look around in the world and see what people have done. The whole question about software patents is much deeper than what we can cover in CS160, so we'll have to postpone that to another day. Okay, we're out of time. That's why, well, we're also out of slides. Good timing. So next time, sketching, storyboarding, and critique, please bring unlined paper and a couple of pens. You're going to be sketching in class. There's a reading up. Don't forget, you have to submit a response. Assignments are due, and if you want to use the lab computer, we have class account forms in the front. So they're here. Come to the front, pick one up. See you on Wednesday.